The perimeter of a sector is a little bit more difficult because people forget often some crucial information. They forget what perimeter means. Perimeter is all of the outside. I know we've said that time and time again, but sometimes we forget exactly what that means. We once again come back to Mr. Innes's crummy drawings of circles. This is 3/4 of a circle. Now, what was the perimeter of a circle? Well, that was the circumference. So, if you remember, that was 2 pi r. That's where we have a radius there, so it's 2 pi r. Now, this is 3/4 of a circle. So therefore, I don't want the entire circumference. I'd want 3/4 of that circumference. So this 3/4 of that 2 pi r, that would be this bit. In fact, why don't we jump to some colour? So that blue section is in fact 3/4 times 2 pi r. What I've got left is this side and this side. Well, it looks very straight and very much like a rectangle. How do we find the perimeter of a rectangle? Well, what we do is we add the sides, don't we? So this would be r plus another r. Or in other words, there's 2 lots of r's. So 2r, so we're going to do some more colour. Remembering that r is the radius, so any is from any point in the centre right to the edge, that is r. So it's 2 radius plus 3/4 times 2 pi r. So for example, let's just fill in some numbers. In this example, the radius is 2 centimeters, so let's fill it in. So this would be 2 times 2 plus 3/4 times 2 times pi times 2. So 4 plus 3/4. 2 times 2 is 4 times pi. Now we can do some fractions here. The 4 down here and the 4 up there will cancel out. 4 plus 3 times pi. So 4 plus 3 times pi. Remember, BODMAS, the times comes first, and then we'll add. So we'll put it into a calculator. So 3 times pi plus 4, and you should get 13.42. We'll round it up to 5. So this is equal to 13.425 centimeters. So remember, this is perimeter, it's the outside, it is not squared. So centimeter, centimeter, it is not squared, it's all centimeters. So what is the moral of the story? What's the main thing? Well, it's basically whenever you're dealing with a sector or a section, you'll have to remember this bit, the bit that's been cut out, so that side, plus whatever fraction it is of the circumference. I'll show you what I mean. We've been given a little sector here. It's a little slice, and we've told that that was 30 degrees, and this is 5 meters. And it's stated in the question here that 5 meters is the radius. We want to find out the perimeter of this section. Well, there's certainly like 2 lots of 5. So, because there's that side and that side, that's the easy bit. Then we've got this section. Now, obviously, it's not an entire circle, it's just a small section of the circle. So the first thing I definitely know is going to be 2 pi r somewhere involved, because it's a circumference. and it's going to be a fraction. Remember, we had a quarter, 3/4, that kind of thing. But what's the fraction? The fraction is exactly the same as the area of a sector. The fraction will be the degrees in here over the total number of degrees there are. So much the same way we had 3/4, well, that was 3/4 of 360, so that's 270 over 360, would have been exactly the same. So 25 plus 30 over 360 times 2 pi r, 25. Make sure to always put equal signs so you know what you're doing. So 3 can go into 36 12 times. We can simplify this again. The 2 and the 12 can cancel out. And now at this point we can now put this into the calculator. If you're wondering why I'm bothering doing complicated fractions and things like that and simplifying and whatever else, it just makes the answers smaller. And when you put answers that are small into a calculator, you're less likely to make a mistake. 1/6 times pi times 5, 2.61799 plus 25. So in my calculator, I'm just going to press the plus sign, 25. Total is 27.618. We'll round it up to 8. This is in meters. So I was almost about to write centimeters there, but would have been wrong and lost a mark. Meters. And that's finding this section there. Here's a different situation. I need to find the perimeter of this entire section. So not a sector, I want everything except the sector. So if I want everything except the sector, the easiest way to do this is to find the sector and subtract. And I'll show you what I mean. For a start, we'll do the easy bits first. So this radius and that. The 10 millimeters here is the radius. So just to remind ourselves, the radius R here is equal to 10 millimeters. Okay? So there we go. That's 10 millimeters. Okay. So what we can then do is that'll be 10 plus 10. So that's those two sides there. Now, what we can do here is I also know that the circumference of an entire circle is 2 pi r, or in this case 2 pi times 10, because the radius is 10. What I'm going to do this time is, since I want everything except the sector, I'm going to take away that sector. So remember, the sector was a fraction, so here it's 20 degrees over 360 degrees times by 2 pi r. So it's basically this section here. That's that section that doesn't exist, this solid line here. That is what we're taking away because we don't want to include it. So what does this mean? I've added those sides. This means the entire circle, take away the bit that doesn't exist. Hopefully that will make a little bit of sense, but we'll see how this works. So 10 plus 10 is 20, plus 2 times pi times 10, I could do 2 times 10 is 20, so it's 20 times pi, minus, so we can do some simplification here. The zeros cancel out, 2, 18, so 2 can go into 36 18 times, so it's 1 over 18 times 2 pi r. The 2 and the 18 can cross cancel each other out, so 2, 1, 9. 2 plus 20 times pi minus 1/9 times pi. Now r here was 10, because that was our radius was 10. And now what we do, need to do all the multiplications first, and then we can do the subtractions. So what we can do here, I would start with the more complicated one first in my calculator. So 1/9 times pi times 10, and that gets me 3.49, let's say 07 millimeters. 20 pi is 62.8319 plus 20. So what I'm going to do in my calculator, is that answer is still in there. So that is still in the calculator with all its decimal places. And now I'm just going to press plus 20. Now why have I done that? It's usually better, more accurate answer if I can keep as many decimal places as possible. So plus 20, and I'm going to take away this number here, so 3.4907. And what I get is a total circumference there of 79.341 millimeters. Remembering, of course, what our measurements were. And there we are. There is the perimeters of sectors, or perimeters of everything except a sector.